Welcome to today's JSS 2 Basic Technology lesson on electronics. Specifically, we will study diodes and transistors. These components are the building blocks of all modern electronic devices, from your mobile phone to computers, radios, and televisions. Electronics is the branch of technology that deals with the controlled flow of electrons through semiconductor materials and vacuum. While electrical technology deals with the large-scale generation and distribution of power, electronics deals with the control of very small currents to process information and control other devices. Before we look at diodes and transistors, let us understand semiconductors. A semiconductor is a material that is neither a good conductor nor a good insulator, it falls in between. The most common semiconductor material is silicon. Others include germanium and gallium arsenide. The key property of semiconductors is that their conductivity can be controlled and modified. This is what makes them so useful in electronics. The conductivity of semiconductors can be increased by adding tiny amounts of certain impurities through a process called doping. When a semiconductor is doped with phosphorus or arsenic, it has extra electrons and is called an N-type semiconductor, N for negative, because electrons are negative. When doped with boron or aluminium, it has gaps called holes where electrons are missing, and is called a P-type semiconductor, P for positive. Now let us study the diode. A diode is a component made by joining an N-type semiconductor to a P-type semiconductor. This junction is called a p-n junction. The diode has two terminals, the anode, which connects to the P-type side, and the cathode, which connects to the N-type side. On circuit diagrams, the diode is represented by an arrow symbol pointing from the anode to the cathode, with a bar at the cathode end. The key property of a diode is that it allows current to flow in only one direction. When the anode is connected to the positive terminal of the battery and the cathode to the negative terminal, the diode is forward biased and current flows freely. When connected the other way, the diode is reverse biased and blocks current flow. This one-way property makes diodes function as electrical valves. The most important application of diodes is rectification, converting alternating current, or AC, to direct current, or DC. The mains electricity supply in Nigeria is AC, the current alternates direction 50 times per second. However, most electronic devices need DC, current flowing in one direction only. A diode or group of diodes called a rectifier is used in phone chargers, laptop adapters, and power supplies to convert AC to DC. A special type of diode is the light-emitting diode, or LED. When current flows through an LED, it emits light. LEDs are used in indicator lights, traffic signals, television screens, and modern energy-saving bulbs. LEDs are far more efficient than traditional bulbs and last much longer. In Nigeria, LED street lights and LED bulbs are becoming increasingly common due to their low power consumption. Another special diode is the Zener diode, which is designed to work in reverse bias to regulate voltage. It is used in voltage regulator circuits to keep a constant voltage even when the supply fluctuates, important in Nigeria where power supply can be unstable. Now let us study the transistor. A transistor is a semiconductor device that can amplify signals or act as a switch. It is made of three layers of semiconductor material, either NPN or PNP, creating two p-n junctions. A transistor has three terminals, the base, the collector, and the emitter. In an NPN transistor, the emitter is N-type, the base is P-type, very thin, and the collector is N-type. In a PNP transistor, the arrangement is reversed. The transistor works by using a small current at the base to control a much larger current flowing between the collector and emitter. This is the amplification principle. A tiny signal at the base, say, from a microphone or radio antenna, is amplified into a large signal that can drive a speaker or transmit information. As a switch, a small base current can turn on or off a large collector current, allowing transistors to act as electronic switches. Billions of transistors in a computer processor switch on and off billions of times per second to perform calculations. The invention of the transistor in 1947 at Bell Laboratories in the United States revolutionized technology. Before transistors, electronic circuits used large, fragile, power-hungry vacuum tubes. Transistors are small, reliable, cheap, and consume little power. Today, a single microchip the size of a fingernail can contain billions of transistors. Applications of transistors include amplifiers in radios and audio systems, switches in computers and digital circuits, signal processors in mobile phones and televisions, and controllers in motor drives and power supplies. In Nigeria, the mobile phone industry has transformed communication and commerce. Every smartphone contains billions of transistors working together in its processor. Understanding diodes and transistors is therefore understanding the heart of the technology that is changing Nigeria and the world. For your examinations, you should know the symbols for diodes and transistors, understand forward and reverse bias, be able to describe the function of a diode and a transistor, and give examples of their applications in everyday devices.